process injection in C#. To begin implementing process injection, we'll generate a project. To start, let's open the Console App 1 Visual Studio solution. And create a new .NET Standard Console App project using the Solution Explorer. We'll call this project Inject. Once this is open, we'll begin to import the 4 required APIs we discussed earlier. Let's start by retrieving the pinvoke OpenProcess DLL import statement on pinvoke.net. We'll copy the DLL import statement into the program class and add a using statement for the interop services namespace. Now that we have the correct syntax for the import statement, let's return to the OpenProcess API's arguments. The first argument is the access right we want to obtain for the remote process. Its value will be checked against the security descriptor. In our case, we request the process all access right, which will give us complete access to the explorer.exe process. In our code, we need to reference process all access by its hexadecimal representation. Next, we need to decide whether or not a created child process can inherit this handle. In our case, we don't care, so we'll simply pass the value false. The final argument is the process ID of explorer.exe, which we can easily obtain through Process Explorer. We can now implement the call to open process. Now that we have an open channel from one process to another, we must allocate memory for our shellcode using virtualalloc.ex, which requires us to perform another import. We'll again use pinvoke.net to find the import. To enumerate the virtualalloc.ex arguments, we'll again turn to the function prototype from MSDN. The first argument is the process handle to explorer.exe that we just obtained from OpenProcess. And the second is the desired address of the allocation in the remote process. If the API succeeds, our new buffer will be allocated with a starting address as supplied in LP address. If the address given with LP address is already allocated and in use, the call will fail. Because of this, it's better to pass a null value and let the API select an unused address. The last 3 arguments mirror the virtualalloc API parameters and specify the size of the desired allocation, the allocation type, and the memory protections. We'll set these to hex 1000, memcommit, memreserve, and hex 40, page execute read write, respectively. After allocating memory, we'll generate a 64-bit Meterpreter staged shellcode with MSF Venom in C# format and embed it in the code. Next, we'll copy the shellcode into the memory space of explorer.exe. We'll use write process memory for this and again copy the import statement from pinvoke.net. Write process memory also takes 5 parameters, and MSDN lists the following prototype. We first pass the process handle, followed by the newly allocated memory address in explorer.exe, along with the address of the byte array containing the shellcode. The remaining 2 arguments are the size of the shellcode to be copied and a pointer to a location in memory to output how much data was copied. Notice that the out keyword was prepended to the out size variable to have it passed by reference instead of value. This ensures that the argument type aligns with the function prototype. The input buffer also needs to be a pointer, but this is inherent in the C# array data type. Next, we'll import create remote thread with the statement copied from pinvoke.net. Once again, we'll check out the arguments from MSDN. This API accepts 7 arguments, but will ignore those that aren't required. The first argument is the process handle to explorer.exe, followed by the desired security descriptor of the new thread, and its allowed stack size. We'll set these to 0 to accept the default values. For the fourth argument, we must specify the starting address of the thread. In our case, it must be equal to the address of the buffer we allocated and copied our shellcode into inside the explorer.exe process. The next argument is a pointer to variables that will be passed to the thread function pointed to by lp_start_address. Since our shellcode does not need any parameters, we can pass a null here. The remaining 2 arguments include various flags and an output variable for a thread ID, both of which we'll ignore. Before compiling the project, we need to set the CPU architecture to x64, since we're injecting into a 64-bit process. After compiling the project, we'll configure a meterpreter listener. And execute our process injecting the shellcode. If all goes well, we'll obtain a reverse shell running inside explorer.exe. The process ID indicates that the meterpreter shell is indeed running inside explorer.exe. We were able to launch our meterpreter shellcode directly inside explorer.exe, which means that even if the original process is killed, the shell will live on. We've successfully injected arbitrary shellcode into another process. Good.